Hey everyone, and welcome. Today, we're going to talk about one of the most powerful ideas in all of probability, and it all comes down to one tiny little word, and. Seriously, it's the secret behind why a super complex system might fail, but it's also the reason your online accounts stay safe. So let's jump right in with something we all do every single day. Think about logging into an app or a website. You know the drill. For that to actually work, you need to type in the correct password, and the server on the other end has to say, yep, that's right, and you need a stable internet connection. It's like a chain with 3 links. If just one of those links breaks, you make a typo, the server lags, your Wi-Fi drops, the whole thing just fails. That chain of ands is exactly what we're here to unpack. Now, in the world of probability, this whole and thing has a proper name. We're not just talking about things happening in a row, we're talking about what's called an intersection. It's the specific point where multiple events all have to happen together. So here's the official definition. An intersection, and you'll see it written with that little upside-down U symbol, it just means the event where A and B both happen. So if event A is the password is correct, and event B is the server verifies it, the intersection is that sweet moment of a successful login. It's basically just math speak for and.
Okay, so how do we calculate the chances of one of these intersections happening? Well, it's not about adding. With and events, you have to multiply. And that brings us to the main event, the core tools for this whole topic, the multiplication rules.
All right, if you're going to pay attention to just one slide, this is it. This is the absolute heart of it. We've got 2 main formulas. The general rule says the probability of A and B happening is the probability of A times the probability of B given that A has already happened. That last part, P of B given A, is what we call conditional probability. It's a huge deal. Then we have a special, simpler case for what are called independent events, where one thing has 0 effect on the other. In that case, you just multiply the probability of A by the probability of B. Easy. So that's the big question, right? You've got 2 formulas. Which one do you use? Well, it all comes down to asking yourself one thing every single time. Does the first event happening change the odds of the second event? Your answer to that one question tells you exactly which path to take. Let's make this super clear with a classic show.
So we're going to put 2 classic scenarios head to head to really nail down the difference between independent events and dependent events. Get ready for the tale of a simple coin toss versus drawing a couple of cards from a deck.
On the left, we've got the coin toss. What's the chance of getting heads and then getting heads again? And on the right, the card draw. What's the chance of pulling an ace and then another ace without replacement? I want you to pay close attention to those 2 little words, without replacement. They change the entire game. This chart just lays it all out. With the coin, the first flip has absolutely no effect on the second. The coin doesn't remember what it just did, right? So the events are independent, and we use that simple formula, P of A times P of B. But with the cards, the first event totally changes the odds. Once you take that first ace out and don't put it back, the deck is literally a different deck. The events are dependent, so we have to use the general formula, P of A times P of B given A. Let's actually do the math for the cards. The probability that your first card is an ace? Well, there are 4 aces in a 52-card deck, so that's 4 out of 52. Simple. But now that card is gone, it's sitting on the table. So what's the probability that the next card is also an ace? Now there are only 3 aces left and only 51 total cards. See? The probability changed. It's 3 out of 51. You multiply those 2 fractions together and you get a tiny, tiny number, less than 0.5%. Okay, so coins and cards are fun, but let's talk about why this really matters. I mean, this rule is at the core of how engineers build safe airplanes, how doctors assess risk, and like we said, how your digital life is protected. The stakes here are absolutely massive. Check this out, because this is where it gets kind of mind-blowing. Let's say you have a system where component A has to work and component B has to work. And let's say each part on its own is 90% reliable. Pretty good, right? Well, the reliability of the whole system isn't 90%. It's 0.9 times 0.9, which is just 81%. By adding just one more and requirement, the system actually got a lot less reliable. This is exactly why multi-factor authentication, or MFA, is such a game changer for security. We're using the multiplication rule to our advantage. To break in, a hacker doesn't just need your password anymore. They need your password, and they need to have your physical phone. The probability of both those things happening at the same time is so much lower than just one of them. or creating an intersection that's incredibly difficult for them to reach. Let's use one last analogy here, one that'll really hit home. Getting a job. It is a perfect real-world example of a dependent event chain. To land that job, you have to pass the resume screening, let's call that event R, and then, if you make it through, you have to nail the interview, event I. Let's imagine only 20% of resumes make the first cut. And of that group that gets an interview, only half of them, 50%, get a job offer. So what's the actual chance for any random applicant to get the job? It's not 20% and it's not 50%. You have to multiply. It's the probability of passing the resume screen, which is 0.20, times the probability of passing the interview given you pass the screen, which is 0.50. And the result? Just 10%. Only 10% of the total pool of applicants will get the job. Each "and" step is a filter, and the multiplication rule tells you exactly how much gets filtered out. So now that we've seen all these examples, from logins to engineering to job interviews, there is one single, incredibly powerful idea that you really need to take away from all this. It's about the fundamental nature of any system that's built on a chain of ands. And here it is. This is the big one. In a series of ands, the system as a whole is always weaker than its weakest link. In fact, it's weaker than any of its individual parts. Every single time you add another step, another component that absolutely must work, you're multiplying by a number less than 1. You are actively making the overall chance of success smaller. More steps often means lower reliability. So let's wrap this up. Here's what you need to remember. First, when you see "and" in probability, your brain should immediately think multiply. Second, you have to ask that one critical question. Are these events independent or are they dependent? Does the first one change the odds for the second one? Third, for dependent events, the order of things matters a ton, and you have to use that conditional probability. And finally, that weird but true conclusion. Adding more "and" requirements actually makes the whole system less reliable, not more. And that brings us to the final thought I want to leave you with. Now that you get the real power of "and", start looking for it. Where is it hiding in your life? In a big project at work? A personal goal you've set? Your morning routine? Where are those hidden chains of events that all have to go right? And more importantly, what's your weakest link? Thanks so much for joining me.